Alright, so we're looking at writing the equations of lines that are tangent to different curves. And the first one I gave you was we're going to be tangent to the curve y equals x squared at x equals 2. So we're going to work this through and eventually get to a point where we're sitting with y equals mx plus b. I usually I'll start there most often when I want to write the equation of a line. But if you look at that y equals mx plus b and what it takes to write the equation of a line, you need a point, so an x and a y. And then you also need a slope. So calculus actually is going to come in when we want to find the slope. So we already have the x. The x is 2. We don't know the m. We can actually find the y real quick as well. And we have the equation of the curve. It says, hey, if you square x, you can get y. And our x is 2. So y equals 4 when x is equal to 2. So we know the x, we know the y, we don't know m yet. That's the slope. Okay. And this slope, this is going to be the slope of the line tangent to y equals x squared at the point 2, 4. Well, calculus helps us find that slope, right? We can take the derivative of our function. So y prime is equal to 2x. So that 2x is going to be responsible for calculating the slope of the tangent line anywhere along x squared. Okay, so if you graph those two together, we can do that real quick. If we graph x squared and 2x, the y coordinates of 2x track the slopes on x squared. So let's try. We'll graph x raised to the second, and we'll graph 2x. So as you look at this graph, the y coordinates of that red line are the slopes on your blue curve. Right? So 2x is the derivative of x squared, and you can look over at the table here and see. So the y coordinates of the red line, that says y2 column, those y values are the slopes, tangent slopes, on the blue curve x squared. So the y values, if you start at 0 and increase x, that parabola is getting steeper and steeper, so you're seeing these slopes go up. Right? And they actually go up by 2 every time, and that's no coincidence because the equation of the derivative is 2x. So we'll go back. That was probably more than you needed there. Anyhow, you can find the slope at the point 2, 4 with 2x. So if you plug 2, 4 into the derivative, well, what do I do with the 4? Well, this derivative says all I need to know is x to tell you the slope. So y prime at 2, 4 is 2 times 2, it's 4. Cool, so we know the slope now, it's 4. So you know x, you know y, and you know m. So y was 4, m was, we said 4, x was 2, and b is unknown. If you solve for the y-intercept here, b, you get b equals -4. So the equation of our line is y equals, let's see, we said slope was 4. So y equals 4x minus 4. So I can do a quick check on the graph. If I look at a graph of x squared and a graph of 4x minus 4, and that 4x minus 4 should be the tangent line at x equals 2. So let's check it. So go to our graph. So x squared and 4x minus 4. Okay. So So if we take a look at our graph, we're looking to be tangent at x equals 2. And it looks like that red line touches the parabola just at x equals 2. See if we can make this bigger. So at x equals 2, we're tangent. So that tangent line just touches the blue curve in one spot, and that's at the coordinate 2, 4. Alright, so next problem, we get a different curve and a different point. So we had y equals x squared times 4x plus 1. And we're going to be tangent at x equals -1. So our point of tangency is at -1 comma, well, I'm going to plug -1 into my function and see what y is. So y equals -1 squared 4 times -1 plus 1. So -1 squared is 1. That'll be -4 plus 1. So 1 times -3, which is -3. So the y-coordinate of the point of tangency is -3. Now we just need to know the slope of the line that's tangent to the curve at this point. So here's my curve, and in the other yellow box you have my point. You're probably going to use product rule on this, which is great. I mean, we're certainly studying that right now, but for me, I'm just going to distribute the x squared in, and I'll rewrite y as 4x cubed plus x squared. So now I don't need the product rule. So y prime is 12x squared plus 2x. I need to know the tangent slope at this point. Notice again, your derivative is just in terms of x, so you actually don't need the y-coordinate, you just need the x. So I'm going to plug in -1, so 12 -1 squared plus 2 times -1. And that looks like it's, so 12 minus 2 is 10. So that's our slope. So you got a point and a slope. And I'll just go to y equals mx plus b. So I'll go -3 equals 10 times -1 plus b. -3 equals -10 plus b. b equals 7. And my equation is y equals slope times x, so 10x plus 7. And we'll highlight that here in orange. So I'll just check my answer real quick. I'll graph the original curve and then the 10x plus 7, and I'll look at when x is -1. So original was, let's see, we can take this out. So I gotta look back at the original. X squared times 4x plus 1. Okay, x squared times 4x plus 1. X squared times 4x plus 1. Okay, and then our tangent line was, let's go back, 10x plus 7. 10x plus 7. We'll turn that on and we'll look at the graph. So we were hoping to be tangent at -1, so that's right. -1 right here. Yeah, it certainly looks like we've written the equation of the line that's tangent to the curve there. Now, maybe I can zoom in and make this a little more obvious. So I'll go -5. And here we can go 0. Okay. So we're tangent to the curve at, looks like -1, -3, and that was our goal. So just a good way to check your answer is to graph them both. Make sure that tangent line is doing what you think it should be doing. Okay, last one. Alright, y equals 3x plus 4 over x plus 1 tangent at x equals 5. First things first, when you plug 5 in for x, you get 3 times 5 plus 4 over 5 plus 1, so you get 19/6. That's going to be y. I need to find the derivative of what I've got there, so that's low d high. The derivative of the top is just 3. So low d high minus high d low. The derivative of x plus 1 is just 1 over low squared. That's y prime. So I can simplify that a little. And that's 3x plus 3 minus 3x minus 4 all over x plus 1 squared. So I'm just finding the derivative so I can find the slope. And if you simplify this, you got 3 minus 4 on top, so a -1 on top, and then that x plus 1 squared on the bottom. So when x is 5, y prime is -1. I should say that when x equals 5, y prime equals -1 over 5 plus 1 squared, which is -1/36. Oh, so I got all these pieces in yellow I'm going to use. The x, the y, and the slope here. So I can finish this off real quick. So y equals mx plus b, 19/6 equals -1/36 times x of 5 plus b. I'm going to go ahead and multiply every term by 36. So if you don't mind, 6 times 6 is 36. I'll put a 36 here and a 36 here. So this was 19/6 -1/36 times 5, and then b right here. Okay, almost there. We're just solving for b. So you got 19 times 6 equals -5 plus 36b. 19 times 6, let's see, 20 times 6 would be 120. 120 minus 6, 114. 114 equals -5 plus 36b. 119 equals 36b. b equals 119 over 36. Final answer, y equals -1/36x plus 119 over 36. Alright. I think that's right. You'll have to check my math. Thank you. Good job.